this is the Piton chip that we taped out in 2015. It's in IBM's 32nm process, and we've got 25 cores. It's about 460 million transistors. And so in this setup, Piton is underneath the heatsink in the fan here, and it's running at 400 megahertz, powered by desktop power supply. We can run it faster on the lab bench supplies, but here, just because we've only got the desktop power supply, that's the frequency we're running at. And then the FPGA is the same FPGA that we use for the chipset when you implement OpenPiton onto FPGA, and it's running at 200 megahertz. And we've got on here an SDHC card that we're using to, we have the operating system image on there, and that's what booted Debian here on the computer. So if I do uname-a, you can see this is like Linux that's running on Spark 64, and I think it's what is etc release, right? Debian version. Then you can see this is Debian Buster SID.
Okay, you don't have anything connected to it, so you cannot do like transferring data.
Right, exactly. We have the Ethernet on here, but we're not plugged into anything.
We're not hooked up right now.
But that's something that we can do. So we have the Ethernet on the board. We're using the Xilinx DRAM controller, and we're using the Xilinx UART here.
Okay.
And then over the last few days, one of our group mates just got VGA and PS2 working, so you can use a USB keyboard, and you can use the VGA, and so like we also have kind of in the lab we've got examples of that. Right?
Okay, but so as far as the CPU and all memory access and all that stuff, everything worked very well.
Everything's working, yeah. So like if I cat proc CPU info, you can see the information about the core.
The CAD is actually running on the processor itself, but not running on the FPGA.
Exactly. So this is the real chip.
Yeah, the real
and
thing.
You can play Tetris.
Okay, there you go.
On our chip. And we've become very very good at Tetris as a result.
Okay.
But this is just Debian Linux, so like if you were connected to Ethernet, like you can just apt-get install different applications.
So, but the idea here is the NOC that connecting all the cores works.
Yep.
The I/O crossbar and all that stuff has been proven, which can be reused by a lot of people.
Exactly.
Right?
And we even have the connectivity here, where the NOC is coming from the chip through this gateway FPGA onto the main FPGA.
Yeah.
So this is PMesh connecting 25 cores. Is being kind of buffered through async FIFOs here onto the FPGA, and then the FPGA is connecting to the I/O crossbar to connect these devices together.
Okay. Thank you.
Sure.